show up in the doesn't show up. It cannot be here. The register is crashed. Or maybe not, because they still have time to think about do they want to register is crashed or not. So they ask the school to provide video and let them to learn something or to understand something. Okay? Don't worry about it, just don't worry about it. Okay, let's continue from the previous time. The last time we said that we want to transform from 3 crude oil to 3 types of gas. Okay, and we only give you some information. Today we'll give you the complete detailed information of crude oil and gas. Okay, actually when you go for fill your gas tank, you have choice. In Taiwan, probably you can choose 92, 95, or 98. It's a little bit like this. It's a different type of gas. They probably have different content. Okay. So the crude oil actually is our source. The different type of crude oil, they have different octane and sulfur content. And they have different purchase price. And they have currently they have the same demand. Not demand, they have supply, they have the same supply. For the different gas, again, they have different octane and sulfur content. They have different sales price. And currently we have fixed demand. But from the last week, we say that the fixed demand can be increased according to our advertisement, right? According to our advertisement, we put more money in advertisement, we can increase the fixed demand. Okay, and the goal. We try to maximize our profit. Okay. Okay. So formulation is that we try to set up for variable. So what will be the variable? Xij indicates
I from close one and J to guess one.
This means that the level of barrel. Of crude oil. I say daily because here we have each day. Okay, and I is 1, 2, 3. Right, we have 3 crude oil, and also J is 1, 2, 3. That's for different gas. So any other variable? Advertising cost. We say the AJ is the money we spend. Okay. Okay. So it means that actually we only need this barrel. We Xij, we will know that how many OUI for gas sake. Okay. And also we have an advertisement. Okay. But it means that we utilize this variable, we can already formulate our formulations. But sometimes, for easier to be read, sometimes we will have some optional variable. For us, easily to check what happened. Okay. For example, we can utilize CI. The CI indicates because here, the purchase price is based on each crude oil. So if I can sum up Xij to Ci, that will be easier to calculate our purchase cost. Okay? And also for the gas, we have sales price. If we can combine the Xij to Gj, it will be easier for us to calculate our revenue. Okay? So for optional variable, it means that maybe we don't need that. But if we utilize that, actually that will be easier for us to understand the formulations. Okay? So I say I want to maximize the profit. So how can I define the profit? The profit actually is the revenue from the gas minus the cost, the purchase cost from, or also the advertisement cost. Okay? So how can I calculate the revenue? Based on this optional variable. We have G1, G2, and G3. That'll be 70, 60, and 50. Okay, and for the cost, we have C1. C1 will be 45 C1, 35 C2, 25 C3. And advertising cost, so A1, A2, and A3. And second, daily production cost. How can I calculate it? Last week, actually, before we write down this table, we have some information. Then I was talking we transform from crude oil to gas. We says that we have a cost to transform 1 barrel of oil to 1 barrel of gas. Okay. So for crude oil to gas, that's 1-to-1. There's nothing lost. So when I utilize 1 barrel of crude oil, I will get after the transformation, I still get 1 barrel of gas. So we can say how many crude oil I use, I need this transformation cost. Okay, and also based on our previous discussions, our previous discussion, do we have any property? C1 plus C2 plus C3. When I mentioned about this transformation cost, I said 1 barrel of crude oil will give me 1 barrel of gas. So here I want to say
Oh,
the relation
G1.
between the C and G.
G1 plus G2 plus
G1 plus G2 plus G3. Okay? Okay. So why do I say they are optional? That's because we have this kind of relations. So it means that actually we can utilize xyz to represent Ci and also utilize xyz to represent Gj. Okay? But again, the optional is help us to understand. Not easily to read what happened. Okay? So here I only focus on C1, Ci for the crude oil, Gj for the gas. Okay? That's the so let me write that. Maximize. I say I want to maximize the profit. So maximize our objective function will be okay, and we still need this for our constraint. That's the objective function. So the next thing is we need to write down the constraint. So let me erase this. We want to utilize this information to help us to write down the constraint. So what should be our constraint?
Fixed demand.
Say again?
The fixed demand.
The fixed demand. How about a fixed demand?
C1 is higher G1, C2 is higher, C3 is higher
G1, G2, G3. G1 higher? Are you sure?
Is
Exactly. But actually it's not exactly 3,000 because we already have advertisement, so the fixed demand could be increased. So
3,000 plus 10 A1.
okay. Oh, okay. The fixed demand could be, let us write it down. It could be 3,000 and
Plus 10 A1.
plus 10 A1. Okay, we mentioned that from next week, we say we have each dollar spent in gas J will increase 10 barrels. Okay? So how about here?
A2.
That will be 10 and A2. That will be 10 and A3. Okay? So to write down the constraint, we start from the very beginning of the crude oil. Let's talk about that. Okay. Initially, I want to start here to talk about the demand, but because he already gave me a correct answer, so let me just write a note. Let me write a note to see what happened because we need that. In the very beginning, let's start from the crude oil. The crude oil, the number of crude oil is a little bit like demand. That's the crude oil. That'll be easier because that's fixed. So C1 should be
5,000.
5,000.
Smaller than 5,000.
Smaller equals to less than, smaller than or less than. So the same idea for C2 and C3. Okay. And for G1, the quantity of G1, that would be what we say the 3,000 plus 10 A1 equal.
Let's say
He say equal. Anyone else?
I think it less equal to that.
Less than or equal. Why?
Because maybe the demand cannot be fulfilled
Maybe the demand cannot be fulfilled.
because it's a maximum profit objective function.
Mm-hmm. Okay. Okay, let's look at this objective function. If I want to maximize this objective function, which one should be maximized? Which variable should be increased? G1, G2, G3 will be increased, right? Once G1, G2, let's take an example of G1. If G1 will be increased, is that possible? Less than the right hand side. Suppose we have 3,000. I have 3,000. When I produce more, I will get more. I will get more profit. Is that possible? Less than. It's possible, but in this example, probably we don't need that because we don't have the other constraint. The constraint will cause less than or equals to not because of this objective function. It could be because of the other constraints. Okay. Okay. So what he say about equal less than or equals to is correct. But when we try to find a maximized profit, the final answer, if everything is C1 is equals to CIE, summation of CI is equals to summation GJ. Finally, we will get this. Okay. Okay. But for formulation, it's also correct. Okay. So for G2, we have 2,000 plus 10 A2. G3 is 1,000 plus 10. Okay. So any other?
0.5%.
Hold on. For the next two concepts, we're talking about octane rating and sulfur content. Okay. For example, octane rating for gas J, which should be greater or equals to some value, and sulfur content should be less than or equals to some value. It means that I will mix different percentage of crude oil, crude oil 1, 2, 3 to become gas 1, 2, 3. They have different octane rating, different sulfur content. Okay, but before we do that, do we still have other?
At most 14,000.
At most 14,000. So G1 plus G2 plus G3 less than. Okay. Okay. So here, can I say equals to 14,000. No, because based on my previous argument, I said maximization, right? I want to increase G1, G2, G3. Since that's at most, how about I just produce to 14,000 barrels? Then I can maximize our profit. Can I say that? Equals to.
But maybe our demand is not fit with the produce.
Yes. Yes. So my it's a little bit like this argument. So it has some restriction. Even I want to go to 14,000, maybe it is not true because we probably have advertisement because advertisement will decrease our profit. Okay. So no, we cannot say that. Okay.
Is it possible to remove that constraint? Because it may be
Redundant because it's less than
yeah, the
14,000.
Yeah, the G value is must.
Hmm.
Yeah.
Is that true? Are you sure?
Oh, because
Let's talk about it. That's our profit. That's our sales price, 70 for each barrel. 70 for each barrel. That's our revenue. Our cost, can say, our cost not just 10, we also 4. We can see that's fixed because we have more barrels, we have fixed. That's for transformation. That's for advertisement. Right. So we have more advertisement. We have more profit. Do we want to increase that?
yeah,
Yes, we want to increase that. Okay, so we still have this kind of restriction. Okay, we probably, as she said, probably we have redundant, but in the very beginning, we don't have any idea. So probably I will write down everything I know. Okay, okay. That's a good point. One day probably you will write down a very complex formulation. And you don't have any idea of which constraint is good, which constraint is are redundant. The easiest idea is run for several examples. Maybe we try to check what happened. Okay, that's the easiest way. But if you want to say that's a redundant, we have to utilize the other constraint to tell us that this one is redundant. But currently, I don't have enough information. Okay, so I have to write that. Okay, so let's talk about octane rating. For different crude oil, they have different octane rating. Okay, for crude oil, that's 12. For crude oil 1. For crude oil 2, that would be 6. For crude oil 3 would be 8. So the next thing is that that's for crude oil 1, crude oil 2, crude oil 3. next question is, which variable should I put in?
X.
X.
Yeah.
Yes, X.
1 1 X 1 1 and X 2 1 and 3 1.
X 1 1, X
2 1.
2 1, and X 3 1.
Well, larger than 10 to 1.
Are you sure? Less than or greater than?
No. I mean, greater than, yeah, I
It should
said.
be greater than 10 G1, okay? But the easiest way, that's the average. That's the average, right? So easiest ways. So the summation of, it means that I combine Kuroyo 1, Kuroyo 2, Kuroyo 3 to becomes base 1. So that's why it meant these three, the summation of these three actually is G1. Okay? Okay? And for different gates, they have the same format, right? For this one is 10. Okay? But different gates, they have different requirements. Okay? So or almost have the same. They probably have the same form, right? So we can combine it together. We just write it down to say for case 6. Okay, for this one is j equals to 1. Okay, and for j equals to 2, that would be 8. For j equals to 3, that would be 6. Right? Okay? For the same idea, we can write down the constraint for sulfur content. That would be, because that's a percentage, average percentage, I should say that's the average percentage. So we can ignore the percentage, just focus on the value. So like the previous one, like this one, with a 0.5, and
Less than 1.
less than 1, 2, and 3 for j equals to 1,
1, 2,
2,
and
1,
1.
2, and 1, sorry. 2 and 1. Okay. So any other constraints? Non-negative, so overall. Return goes to 0. Okay. So questions? come back to talk about, previously I said G and C, they are optional. So we can go back to talk about it. Previously we said Gj actually is equals to x1j plus x2j plus x3j. Okay? So I utilize the optional, that's so easy. I utilize one character to represent everything. But if I didn't have this kind of optional variable, means that here I have to put down x11 plus x21 plus x31. So we have a lot of variables here. Okay? So that's your choice. Okay? You can utilize optional, but to be more, we probably have a lot of variables. Okay? For some complex formulation, this optional variable sometimes will help us to put this, try to let this formulation easier to be read. Okay? But when we try to solve it, we don't like that. Because we have more variables, right? Because we have 6 more, G1, G2, G3, and C1, C2, C3. And you already you already know how to solve the problem. We have more variables, we have more computation time. Okay? But for formulation, we prefer this formulation more compact and we will easy to understand. Okay? We have different choice to formulate a problem or to solve a problem. We have different considerations. So it's not just easy as let's say, okay, I have a formulation and then put everything into the software and then it solve it. No. Once we try to solve it, we have another problem. But we will talk about it later. Right now we only focus on formulation. So right now we only focus on how can we easily understand the formulations. Okay. Okay. Let's have another example. That's in your textbook, section 3.10. That's a multi-period decision problem. Again, it's related to formulation. Okay, we write down. Okay, as a multi-period decision problem, it means that we have only have 4 months demand. So different months we have different demands, 50, 60, 500, and 75. And for each month we have different production costs. Okay, so as you expect, can we choose the less production cost and produce a lot of things? Try to fill every demand. If we can do that, we will try to do that. Okay? Okay, because at this time probably have the largest production cost, so we try to avoid that. Okay? So if you are a manager, probably you try to think about that. Can we use that as less production cost to meet our demand? Okay. But the following is two considerations. One is the storage cost from 1 month to the next one. It's $2 for each unit. So it means that I can produce for the first month. For the first month, I can produce more than 50 units, and to meet the second month's demand, right? Once we do that, to meet that we only need 5 plus 2, $7. Much less than this one, okay? Because we only have 4. Let me complete this. Because we only have 4 months. In the end of this month, if we produce more than our demand, we just sell it for $6. Okay, more than I'll just. Okay. So the goal is that we try to minimize the cost. We try to make a decision in this, which month should produce how many units. Okay? Have a break.